Hello students, good evening. Today we are going to start new chapter Human Eye and Colorful World. Mainly this chapter divides into two parts. One is Human Eye and second part is Colorful World. So in the Human Eye we are going to study about least distance of distinct vision and angle of vision. After that study about structure of the eye, and next vision defects. Due to the adjustment of the focal length of the eye lens, we have three eye defects. One is myopia, and second one is hypermetropia, and third one is presbyopia. To correct these eye defects when we are occurring, at the time which type of lens we have to use, that is concave and convex and bifocal lens, and what is the power of those lens. This is the one one phase, and the second part is colorful world. In this part we are going to study of the light phenomena such as dispersion and scattering. Dispersion and scattering both are the properties of the light energy, and also how the Vibgyor is formed. Due to this Vibgyor, when the light ray incident on the one side of the prism, at that time what happens, and also how the rainbow is formed. So from this phenomena of light dispersion we can study all these topics. Next, scattering. Scattering is also one of the property of the light. So sometimes sky appears in the blue color, sometimes sky appears in the white color, sometimes sky appears in the red color. So what phenomena behind those changes of the sky? So that is the scattering. So this is the main two parts which are involved in this chapter. Least distance of distinct vision. So what is meant by least distance of distinct vision? For example, if you take any newspaper or textbook and arrange those newspaper or textbook in front of your eyes and observe the letters which are existing in that, and also after that you move those newspaper or textbook towards your eye, what happened? The letters which are existing on that book gets blurred. Again you move those book opposite to your eye up to certain distance where you get clear vision of those letters. Those distance is called least distance of distinct vision. Do this activity for more persons and calculate the average distance where those persons get clear vision or distinct vision of those letters when they put newspapers or textbooks in front of their eyes. So those distance, the average distance of all those persons nearly 25 centimeters. That's why we can define the least distance of distinct vision as the minimum distance at which we can see the letters of the books or newspapers very clearly. Those distance is called least distance of distinct vision. For any healthy human being, this distance is nearly 25 centimeters. It is not a constant value. It varies from person to person due to their age and due to their health conditions. For example, for younger children or kids, the least distance of distinct vision is nearly 10 to 15 centimeters, because the nerves which are existing around our eye for those persons, means those kids or those younger persons, is very strengthy and flexible, so that they see the letters of the any newspapers or books when they put nearly 10 to 15 centimeters in front of their eye. For aged persons, the least distance of distinct vision is nearly 80 centimeters to 100 centimeters due to their age and their health conditions. But for any healthy human being, the least distance of distinct vision is 25 centimeters. So it is a not constant value. It varies from person to person. Once again, the least distance of distinct vision can be defined as the minimum distance at which the letters of any books or the letters of any newspapers appear very clearly or very distinctly. Those distance is called least distance of distinct vision. For any healthy human being, the least distance of distinct vision is 25 centimeters, but it is not a constant value. It varies from person to person due to their age and due to their health conditions. Just now we said that the least distance of distinct vision for kids or younger persons is nearly 10 centimeters, 10 to 15 centimeters, because the nerves which are located around their eyes are very flexible and very strengthy, so that the value decreases for those persons. And also for aged persons, the least distance of distinct vision is nearly 80 centimeters to 100 centimeters, because of the nerves which are located around their eyes are not flexible, and also they are weak due to their age, so that the value of the least distinct vision is increased for aged people. So for any healthy human being, the least distance of distinct vision is 25 centimeters. If the value of 25 centimeters least distance of distinct vision increases, maybe 30, 35, 40, those person must have some eye defects. Okay, so the minimum distance at which any person who can see the letters of any newspapers or letters of any books very clearly or very distinctly, those distance is called least distance of distinct vision. Next, angle of vision. So the value of the angle of vision for any human being is 60 degrees. What is the angle of vision? What is meant by angle of vision? So the maximum angle at which any person who can see the both ends of any vertical subject, those angle is called angle of vision. Here we are getting two values. One is least distance of distinct vision, that is 25 centimeters, and angle of vision is 60 degrees. Once again, angle of vision, the maximum angle at which any person who can see the both ends of the vertical object very clearly without any rotation of his eyes, those angle is called angle of vision. Those angle is called angle of vision. So for any healthy human being, the value of the angle of vision is 60 degrees. So now we are going to study about the structure of the eye. So eye is very sensible and important organ in the human body. It enables us to see all the objects and all colors around us. The structure of eyeball is like this. The structure of eyeball is spherical in shape. Spherical in shape. The front portion of the eyeball is sharply curved. So it is covered with a protective and transparent membrane is called cornea. Behind the cornea there is a place filled with a liquid. Those liquid is called aqueous humor. Behind this one lens is existing. Those lens is called eye lens. eye lens. This lens is in the shape like this. At its edges it is very thin, but at its center it is very thick. That's why we can say that eye lens is also nothing but biconvex lens. Between aqueous humor and eye lens, one colored diaphragm one colored muscular diaphragm is existing. Those is called iris. At its center, one hole is there. Those hole is called pupil. So, behind the eye lens, at the distance of 2.5 centimeters, one screen is existing. Those screen is called retina. So, what is the purpose of retina? Here, when we see the objects which are placed at distinct distances or near distances, in both times the image is formed on the retina. So retina, the distance between eye lens and retina is only 2.5 centimeters. So eye is a very sensible and important organ in the human being. It enables us to see the all objects and all colors around us. The eyeball is spherical shaped. The front portion of the eyeball is curved. It is covered with a transparent membrane is called cornea. Behind the cornea, there is some places existing. Those places filled by one liquid. Those liquid is called aqueous humor. Behind this aqueous humor, one lens is existing. Those is called eye lens. Between the aqueous humor and eye lens, there is a colored muscular membrane is there. Those muscular membrane is called iris. So at the center of the iris, one hole is existing. Those hole is called pupil. Behind the eye lens, at the distance of 2.5 centimeters, one screen is existing. The screen is called retina. So on which the images are formed when we see the objects at far distances or distinct distances or near distances. So this is the parts and structure of human eye. So here any light ray which enters into the eye through the pupil. For example, sometimes we are seeing the objects in less light conditions or dark conditions. Sometimes we see the objects in high light conditions or bright conditions. At the time, for example, when we see any objects in the dark conditions, at the time the pupil expands by the help of iris. In the bright conditions or when the high light is present, at the time the pupil gets contract by the help of iris. That's why we can say that iris is a variable aperture. Okay. When we see any objects which are nearer to our eye or which are far from our eye, in both times the image is formed on the retina. So here the image which is formed on the retina is real image or virtual image. So the image which is formed on the retina when we see the objects by using our eye is real image. But we perceive those images of those objects is same in size, same in color and erected. How is it possible? For example, if we see the objects at far distances, or at distinct distances, at infinite distances, at the time the focal length, the focal length of the eye lens becomes maximum. How is it possible? By the help of ciliary muscles. By the help of ciliary muscles. By the help of ciliary muscles, our the focal length of the eye lens is adjusted. For example, if we see the objects which are placed at far distances, at the time the eye lens, the focal length of the eye lens becomes maximum because the ciliary muscles gets relaxed. The ciliary muscles gets relaxed because when we see the objects at far distances, at the time ciliary muscles gets relaxation, so that the focal length of the eye lens becomes maximum. When we see the objects very near, those objects are placed very near or least distances, at the time the ciliary muscles gets some strain, so that the focal length of the eye lens becomes minimum. So here the focal length sometimes becomes maximum when we see the objects at far distances. The focal length of the eye lens becomes minimum when we see the objects, when we see the near objects by the help of ciliary muscles. That's why we can say that the adjustment of the focal length of the eye lens by the help of ciliary muscles is called as accommodation. Called as accommodation. So when the image is formed on the retina, here we already said that the image which is formed on the retina of the eye is real image. So we have already known that the properties of the real image. Real image is inverted image. Real image requires one screen to catch it. Okay. But if we see the any objects which are in our surroundings, the images of we perceive the images of those objects very clearly, means they are in same size, they are in same color. How is it possible? Because the screen of the eye, human eye, contains nearly 125 millions of receptors. Such as Holmes 125 millions of the receptors, such as Holmes, and second one is rods. Cones and rods. So these receptors receive the light signals in such a manner. Cones identify the colors and rods identify the intensity of the light. So this processed information transfers to the brain through the optic nerves. So in our brain, this information interpretation and processed so that we perceive the image of any object very clearly, and those object is in the same size, those object is in the same color. So here one important thing is, when we see the objects which are placed at distinct distances, at that time the focal length of the eye lens becomes maximum by the help of ciliary muscles. What is the maximum focal length of the eye lens? When we see the objects which are placed very nearer to our eye, at that time the focal length of the eye lens becomes minimum by the help of ciliary muscles. What is the minimum focal length of the eye lens? Now we are going to discuss maximum focal length of the eye lens and minimum focal length of the eye lens. So the adjustment of the focal length of the eye lens by the help of ciliary muscles is called as accommodation. Now we are going to discuss about maximum focal length of the eye lens and minimum focal length of the eye lens. Now we are going to discuss about maximum focal length of the eye lens. Just now we discussed about when we see the objects which are placed at infinite distances or distinct distances or far distances, at the time the ciliary muscles gets relaxed so that the focal length of the eye lens becomes maximum. Okay. For example, the light rays which comes from the objects which are placed at maximum distances. We have already known that wherever the objects are placed, for every case, the image is formed on the retina. So the distance between eye lens and the retina is 2.5 centimeters. Here, by using lens formula, we can find the maximum focal length of the eye lens. So, what is the lens formula? 1 by f is equals to 1 by v minus 1 by u, where f is the focal length of the lens, v is the distance of the image, and u is the distance of the object. So here it is very clear that the distance of the image is 2.5 centimeters because the distance between eye lens and the retina is 2.5 centimeters, so that we consider the distance of the image is 2.5 centimeters. According to the sign conventions, while measuring the distance of the image from the optic center of the eye lens, we are moving in the direction of the incident light so that it becomes positive value. Next, distance of the object. Here, where we place the object, we see the objects which are placed at distinct distances or far distances or infinite distances, so that we are considered distance of the object is infinity. While measuring the distance of the object, we are moving opposite to incident light direction so that we get negative value for the distance of the image. So substitute these values in this equation, we get 1 by v. V is how much? 2.5 centimeters minus 1 by u. U is how much? Minus infinity. Minus of minus plus. 1 by f is equals to 1 by 2.5 minus of minus plus 1 by infinity. 1 by f 1 by f is equals to 1 by 2.5. So, f max or maximum focal length of the eye lens when we see the objects at far distances is equals to 2.5 centimeters. So, it is the constant value. So, the distance between eye lens and retina is also 2.5 centimeters. And also the focal length, maximum focal length of the eye lens when we see the objects which are placed at distinct distances is also 2.5 centimeters. Okay. Now we are going to start minimum focal length of the eye lens. So when we see the objects which are placed at least distance of distinct vision, we have already said that what is meant by least distance of distinct vision? The minimum distance at which we can see the objects very clearly, those distance is called least distance of distinct vision. For any healthy human being, the least distance of distinct vision is 25 centimeters. If any objects which are placed at least distance of distinct vision, at the time what happened? The ciliary muscles gets some strain so that the focal length of the eye lens becomes minimum. In this case also, the image is formed on the retina. So the distance of the image for every case when we see the objects which are placed at far distances or when we see the objects which are placed at least distance of distinct vision or near distances, in both cases the image is formed at 2.5 centimeters distance from the eye lens where the retina is existing. So to find the minimum focal length of the eye lens in this case, again we are using lens formula. 1 by f is equals to 1 by v minus 1 by u. Here v is equals to 2.5 centimeters. While measuring the distance of the image from the optics from the eye lens to the image, we are moving in the incident light direction so that it takes positive value. The distance of the object. The object is placed at least distance of distinctive vision so that it is 25 centimeters. While measuring this distance, we are moving opposite to incident light direction so that we take negative sign minus 25 centimeters. Substitute these values in the given equation or above formula. 1 by v, 1 by 2.5 centimeters minus 1 by minus of minus 25. So 1 by f is equals to 1 by 2.5 minus of minus plus 1 by 25. So to remove the decimal point in the fraction, so we have to multiply both numerator and denominator with 10. Then we get 10 by 25. 1 by f is equals to 10 by 25 plus 1 by 25. So that 1 by f is equals to, these are similar fractions because both are having same denominator. 10 plus 1, 11 by 25. So we get the reciprocation on both sides of the equality. We get f is equals to 25 by 11. This is equals to 2.27 centimeters. So this is the minimum focal length of the eye lens when we see the objects which are placed at near distances or which are placed at least distance of the distinct vision. So f max is equals to 2.5 centimeters. F minimum is equals to 2.27 centimeters. Here the focal length of the eye lens adjusted by the help of the ciliary muscles. That's why we can say that the adjustment of the focal length of the eye lens by the help of ciliary muscles is known as accommodation. So f max is equals to 25 centimeters and f minimum is equals to 2.27 centimeters. When we see the objects at far distances, at that time the focal length of the eye lens becomes 2.5 centimeters. When we see the near objects, at that time the focal length of the eye lens becomes 2.27 centimeters. So the lower limit of the focal length and the higher limit of the focal length. If beyond these measurements we can't see the any objects properly, so that the maximum focal length must be 2.5 centimeters, the minimum focal length must be 2.27 centimeters. Okay.